y equal to 2x2 plus 4x x squared plus 2x plus 5. So this is the example that we're gonna investigate. So first time, what do you do? So you factorize the numerator, so we get x, and then here we get 2. And below we have a quadratic function, so you need to factorize this one, so we get an x. So we will pick so this one should be minus 15, not plus 5. It's minus 15. So we'll pick 5 and 3, and we'll put plus 5, and we put a minus 3 there. So then you double check everything, this is correct. So this one already in a fully factorized form, so we actually will start working with this, right? So as usual, first information, we go and find out the domain. So we put denominator cannot be 0, x minus 3, x plus 5 cannot be 0. So the x cannot be 3, x cannot be negative 5. All right. Next information, we will go and find the intercept. So we start finding the x-intercept first. So x-intercept, set the y equals 0. So below is x minus 3, x plus 5. So the 0 times the whole thing, so end up 0 equal to 2x, x plus 2. So in this case, we have 2x intercept because x equal to 0. The next one is your x equal to minus 2. 0, 0, minus 2, 0. All right, next move on to find the y-intercepts. Okay, y-intercept we have is we'll put the y here, then all the x will label it as 0. So 0 minus 3, 0 plus 5. So what do we get? On top is 0, and you're going to divide by negative 15 below, so we get 0. So we get 0, 0. Okay, so we will put the graph here. So we have 0, we have minus 2. That's it, right? 0 and minus 2. Okay, the third information that we can find is known as your vertical asymptotes. So take dx, set it to 0, x minus 3, x plus 5 equal to 0, x equal to 3, x equal to minus 5. So put it minus 5. So let me make it longer here. So x equal to minus 5 is somewhere here. So we have a dotted line somewhere here. Okay, x equal to minus 5. X equal to 3 is the other side. So we have another dotted line, which is of VA over here. X equal to 3. All right, and next, item number 4, we will actually go and find out whether we have a HA or whether we have a OA. So we need to compare the degree. So sometimes we use this one, sometimes we use this one. But in order for you to find out the horizontal or oblique asymptotes, we are referring to this one. So as you can see, the degree of the numerator, which is the one on top, what do you think is the degree of the numerator? So you can see that it's on top is 2, which is comparing to the denominator also is 2, so it's equal. So the degree of the numerator is equal to the degree of the denominator. So when this happens, we will have a horizontal asymptotes, and the oblique asymptote is not exist. So next, what is the equation of the HA? So you say y equal to, you are taking the leading terms of the numerator. So in this case will be 2 divide by the leading terms of the denominator. In this case is 1. So y equal to 2 over 1 means is y equal to 2. Label it in the graph. So this is my y equal to 2. Next, we look into the last part here where we analyze the what they call that, the interval analysis. Intervals analysis. So first we need to get the x value in order for us to partition it into several parts of the graph. So how do we get the x value? So to get the x value, what we need to do, we need to set the numerator equal to 0 and also the denominator equal to 0. So basically using the function here. So numerator, once we set it to 0, we get 2x value. First one will be 0, the second one we get will be minus 2. Alright, when we set the denominator equal to 0, we get another 2 more x value. We get 3 and we get minus 5. Alright, from this 4x value, to arrange it from a small to a big value. So both n is infinity. So we'll start with minus 5 here, move on to minus 2, move on to 0, then move on to 3. So you can see that it actually divide the x-axis in the graph into 5 parts here. So we have 5 intervals. We need to test the intervals here. So we are using the numbers suggested into each intervals to test the y value. So the first intervals, negative infinity and minus 5, we can pick minus 10, for example. Alright, let me copy down the function first. So y equal to 2x, and then here is x plus 2, and we have another one, x minus 3 at the denominator, and x plus 5. Alright, second intervals, I will between minus 5 minus 2, I can pick minus 4. Alright, third interval, minus 2 and 0, I can pick minus 1. And 0 to 3, I can pick 2. And 3 to infinity, I can pick 10. Alright, we will do the we will go and find out the y value. So we start with the first, alright, x value, which is minus 10 that we suggested. So minus 10, so all this we will put minus 10 here also and here also lah. So in order to minimize the mistake, you do it one by one. Alright, minus 10 here. So basically this one I can just put into the brackets. Alright, so minus 10 times 2 is a negative. Alright, second brackets, minus 10 plus 2, we get a negative. You're going to divide by minus 10 minus 3, negative. Minus 10 plus 5, negative. So on top is nene, we get por. Below is nene, we get por. So overall we get is positive. Right, let's make the intervals a bit bigger here. Alright, okay, so we already get the first part. Next, proceed to the next part here. So we will pick minus 4. So minus 4 over here, we will get negative. Minus 4 plus 2, second, we will get the negative as well. Divide by negative 4, negative 3 is negative. Negative 4 plus 5 is positive. So ne we get por. Por ne we get ne. So overall we get negative. Okay, third one, negative 1. So on top negative here. So here is positive. So here we get negative, and here we get plus. So on top is negative, below is negative, overall plus. Okay, the interval number 4, we get positive, we get positive, we get a negative, and we get a positive. Alright, so on top will be plus, below will be negative, so overall will be negative. Okay, the last one, of course, definitely all will be plus here. Plus, plus, divide by plus and plus as well. So overall is plus divided by plus. So overall we get is plus. Okay, so this is very important. We have to use this information in order to help us to plot the graph. So let's just go back to the graph here. So the graph on top here show that, okay, the first interval is negative infinity to minus 5, means this part of the graph. We see that there's something plus. So the sign is plus, means there's something above. So means something here. We cannot put here because when you put here, they will cross over the intercept. Sorry, the asymptote. So I have to put something over here. So we should have the graph over here, this part. All right. Second interval is minus 5 to minus 2. So means it's between here. Minus 5 to minus 2, this part here. The interval analysis show that is something negative. So there's something below the x-axis. So means nothing above here. There's something below here. So that's why you can see a minus 2. Okay. So this is a minus 2. Let me write properly. So minus 2. So means there will be something like this. Okay. And between the next interval, the third one, minus 2 to 0, there's something above. As you can see, plus. So means this part here, there's nothing below here. There's something above here. So and then there's intercept. Of course, you have to join here. Okay. And then come down here. 0 to 3, which is this part, you see there's something negative, means there's something. This part here means we have something below here. Alright, so basically it's an N shape here lah. Come here. Alright. And the last intercept, which is the between 3 and plus infinity, means it's something here. There's a plus sign, so means there's something above the graph, above the x-axis. So once again, here. So this is your graph of the rational functions. All right.